All right, guys, we have a quick example here, a related rates problem. Section 311 if you're in the Briggs book, or section 3.7 if you're in the Larson book. Now we have a hemispherical tank with a radius 9 meters. It's filled at a rate of 5 meters cubed per minute. How fast is the water level rising when the water level is 8 meters from the bottom of the tank? Now this hint is nice here because I would not know this off the top of my head, nor would you most likely. This right here. Okay, that is the volume for this partial, for this portion of a sphere. So it's not half of a sphere. It's just a sphere that is this portion where h is in this case going to be 8 meters, and we have a radius of 9 meters. Okay, so again, I wouldn't expect you to know this formula. I would expect you to know the volume of a full sphere, but this partial sphere, I wouldn't expect you to know that. So we're given this, so we can say that volume equals, now let's see, pi h squared 3. Now I'm going to actually put a 9 here because the radius is 9 meters. Now notice I did not substitute in for h because h is changing. Okay, the height of the water level is changing as the water comes in, but the radius of the sphere is not changing. Okay, so I can substitute that 9, no issue, but I don't want to substitute the h because h is varying here. Okay, so I can simplify this a little bit. Oh, over 3, sorry, I forgot that part. All divided by 3. Okay. So let's see here. I can simplify that slightly. I can say pi over 3. You'll see why I'm doing that in a second. H squared. Then we'll say h squared 27 minus h. Okay. Now, if I want to take the derivative of this volume equation, I could say that the derivative of volume with respect to time, now I can factor out that pi over 3, and then I need to use a product rule. Okay? I have two functions. I have this function h squared, and I have this function 27 minus h. You certainly could distribute and get the exact same answer. Distribute, then take the derivative. I'm just going to use the product rule. So the product rule says that you take the derivative of the first function, that gives us 2h, okay? Then multiply by the second function. So I'll say actually 27 minus h times 2h, but when I take the derivative of h squared, I don't just write 2h, I write 2h times dh dt according to the chain rule. Then I add this to the derivative of the second function. Now the derivative of the second function is 0 minus 1 dh dt. So it's actually negative dh dt times h squared. So I'll say h squared times dh dt. Okay? That's the second function, or excuse me, the first function times the derivative of the second. Okay, so there's my derivative. Now, what am I actually solving for here? I'm asked to find how fast the water level is rising. Now, that tells us, height is the height. H is the height of the water. So, how is the water level rising? How fast is it rising? That's dh dt. So we need dh dt. Water level rising. That is dh over dt. Now, we're told, let's see, we've already taken this into account, that it's 9 meters is the radius, and we want to then look at the other information we have here. This 5 meters cubed, that means how fast the water is coming in, the inflow. Okay, that 5 meters cubed, that's how fast the volume is changing. So the derivative of volume with respect to time is 5 meters cubed. Then what about this 8? That's where we're concerned. We're concerned with what's going on when it's 8 when the water level is 8 meters high, so that's h. Okay, so now let's make all of these substitutions and see what happens. So dH dt, that is, that's what we're looking for. dV dt is 5. So we can say that 5 equals pi over 3. Now we have 27 minus h is 8, times 2 times h, which is 8. Okay. Let's see. Oh, times dH dt. Okay, minus h squared, that's 8 squared times dH dt. All right, so we have 5 equals pi over 3 times, okay, let's see here. We have 27 minus 8. It's 19. 19 times 2 times 8, so 19 times 16, I get 304. So 304 dH dt minus 64 dH dt. Now let's multiply both sides by 3 over pi. So we get 15 over pi equals how many dH dt's are left over? Well, I think that's, what, 240? 240 dH dt. So to solve for dH dt, I just need to divide both sides by 240. So let's see, 15 divided by 240. We get 1 over 16 pi. So let's see here. Scroll down. Oh, let's just do this. Let's go up here since we're out of room. And so we can say that this right here is 15. We're dividing both sides by 240. So 240 pi, which equals 1 over 16 pi. So that is dH dt. Now, units. Let's not forget units. So we're talking about the water level rising. So that's going to be in meters, and we are talking about per minute. So this is 1 over 16 pi meters per minute. Okay, we're just talking about length, so it's just meters to the first power. If we were talking about area, it would be meters squared. If we were talking about volume, it would be meters cubed. But here we're just talking about length, so it's meters per minute. Okay, so there is our final solution. Okay, so just to recap what we did here, we always want to find our equation that relates the variables in question. Here was a piece of cake since we were given that equation. We then want to take the derivative of both sides with respect to t. We then substitute in the information we do know and then solve for the piece of information we're looking for. Of course, we had to figure out the givens. Here we were given that the derivative of volume with respect to time was 5. We were given that the height was 8, and we needed to look for the change in the height, which is dH dt. So it takes a little bit of practice to understand what's being given to us and what's being asked. So we have to translate this stuff into dVs, dTs, dH dTs, stuff like that. So practice is key here. If you need any more help, just let me know. I'm always glad to make more tutorials for you. So talk to you soon. Always feel free to ask if you need more help.